Page 1 of probability. Probability is the chance or likelihood that an event happens. It assigns a number from 0 for an impossible event to 1 for a certain one. A probability of 0.5 has an equal chance of happening as not happening. It's like a 50% chance of happening. Terms for experimental probability. Number of trials is the total number of times an experiment is repeated. Outcome, different results possible in one trial of an experiment. Frequency, number of times a particular outcome occurs. Relative frequency, outcome frequency divided by the total number of trials. It can be used to calculate the experimental probability. Okay, let's go to problem 1. When a batch of 145 paper clips was dropped onto a 6 centimeter by 6 centimeter squared paper, it was observed that 113 fell completely inside the lines and 32 finished up on the grid lines. So 113 fell like this inside, and then 32 ended up on the line like that one. Find to 2 decimal places the experimental probability of a clip falling inside a square. Okay, so one of the things we need is the total number of trials, which they didn't give us, but we can kind of calculate it. We can calculate it by adding up 113 with 32. That gives us 145, right? Yeah. Okay, so what is the experimental probability that a clip falls inside a square? Well, that we could find it just by finding the outcome frequency divided by the total number of trials. So 113 divided by 45. Let's use the offline calculator for that. 113 divided by 145 is 0.779. They asked for two decimal places, so it would be 0.78. Okay. Then it asks the same thing for on the line, so that would be 32 out of 145. So that would be 0.22. Okay. Number 2. Jose surveyed the length of TV commercials in seconds. Find to 3 decimal places the experimental probability that a randomly chosen TV commercial will last between 29 and 30, more than a minute, between 20 and 59. Okay, so let's see. Between 29 and 30 seconds, that would be this row here. It happened 38 times. If we figure out the total number of trials, then we could find the frequency by dividing 38 by the total number. So let's use the offline calculator. 17 plus 38 plus 19 plus 4, total of 78. So that would be, for A, it would be 38 divided by 78. Let's divide that. We get 0.487. With 3 significant, three decimal places, we're going to get 487. Okay. What about B? More than a minute. So that would be 4 divided by 78. 4 divided by 78, which would be 0.0513. 0513. Oh, but it asks for 3 decimal places. So 3 decimal places would just be 5, 1, and that's it. Okay? C. Between 20 and 59. 20 and 50. Well, this is a more difficult one. It's 2 categories together, 20 and 59. So it'd be 38 plus 19, 57, divided by 78. That would be 0.731. 0.731. Okay. What about number 3? Betul records the number of phone calls she receives over a period of consecutive days. For how many days did the survey last? So number of calls per day, number of days. So how many days did the survey last? I think we're going to have to add up all these bars. So we got 2, we got 7, we got 11, we got 8, we got 7 again, we got 4, we got 3, I think. This would be 3, this would be 0, and 1. So let's add those up together. 2 plus 7 plus 11 plus 8 plus 7 plus 4 plus 3 plus 1. 43. So the total number of days is 43. And for example, 2 of those 43 days, there were 0 number of calls. 3 of those 43 days, there were 6 calls, etc. So 43, I'm going to put here. Estimate her chance of receiving no phone calls in one day. So that would be, no phone calls would be 0, so that would be 2 out of 43, which is 0.0465. Okay. What about number 2? 5 or more calls in a day. So that would be 5 calls, 6 calls, 7 calls, 8 calls. So that would be 4 plus 3 plus 1, I think. So that would be 8. 8 divided by 43. 8 divided by 43. 0.186. Okay, last of all, less than 3 phone calls in a day. Less than 3 phone calls a day, that would be 0, 1, or 2. So I would add up 2, 7, and 11. 2 plus 7 plus 11 gives me 20, so the fraction is 20 divided by 43. And then I calculate that, it's going to be 0.465. Okay, and that's it for page 1. Let's move on to page 2. Pat does a lot of traveling in her car, and she keeps records on how often she fills her car with petrol. The table alongside shows how the frequencies of the number of days between refills. Estimate the likelihood that there is a 4-day gap between refills. There is at least a 4-day gap. There is at least a 4-day gap between refills. Okay. So, what's the likelihood that there are 4 days between refills? That happens 17 times out of, we don't know, we've got to add them up again. 37, 81, 48, 17, 6, and 1. Okay, so 190 total refills. 17 of those times there were 4 days in between. So for A, we're going to say 17 divided by 190, which is 0.895. They didn't say how many significant figures to leave there, but I'll leave 3. Okay, so B. There is at least a 4-day gap between refills. So that would be between 1 and 3 days between refills, which would be these numbers added together, 37, 81, and 48, which gives 166. So 166 divided by 190 is equal to 0.874. Okay. Alright, 22b, about sample space. U, the universal set, represents the sample space, the set of all possible outcomes of an experiment. Okay, so here are 2 common ways to show the sample space. One is to make a grid where you have the two results which combine to make kind of a compound event on each axis, and then you have the tree which has the same thing, except for instead of having 2 axes, it kind of has like 2 steps. Okay, the tree can be used in more complicated experiments where you have 2 or more phases, whereas the grid can only be used if you have basically 2 variables. Okay, list the 4 possible outcomes from the grid. Well, we got heads, heads. This is obviously a coin flip, right? We got tails, heads. We got tails, tails. Oh, I'm sorry, look at that. I'm doing coin 2 first instead of coin 1. Actually, heads, heads, and then this would actually be heads, tails. I'll write that down here. And then this would be tails, heads. Oh, we already wrote down tails, heads there. Okay. And last of all, we have tails, tails. Oh, we already wrote down tails, tails. Okay. So we have 4. List the 9 possible outcomes from the tree. Okay, it's easier if we write them here. RR, RG, RY, GR, GG, GY, YR, YG, and YY. Okay? Alright. For 1, A and C only. List the sample spaces for the following. Twirling a square spinner labeled A, B, C, D. Oh, okay, a square spinner labeled A, B, C, D could give results or outcomes of A, B, C, and D. If you put them in a list like this, you could put them in brackets like they're in a set. Now C, the order in which 4 blocks A, B, C, D can be lined up. This is a little bit harder. Whenever you do these kind of problems, which probably not are going to be on the test, but they're kind of good exercise for you to see, it's good to be organized. And so, for example, in this one, let me show you how I did it. I put all the combinations started with A first, all the combinations that started with B second, and then I'll do the same thing with C's, and I'll show you how I do those. D, 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 D. Okay. Now I'm going to say, okay, what are the combinations that start with C? Well, there's CA, CA, CB, CB, and CD, CD. Those are the beginnings. And then CA, the only 2 combinations are left are CADD, CADB, CBAD, and CBDA, and CBAB, and CDBA. Here, same thing. Be organized. There's DADA, there's DBDB, there's DCDC. Here, the only 2 combinations would be DACB and DABC. This would be DBAC and DBCA. And this would be DCAB, and this would be DCBA. Okay. So, those are the 24 combinations, the 24 orders that the 4 blocks can be lined up. Okay, and that was page 1 and 2.